Hello, my dear physics friends. This is Chandamala Chandrasekhar. Welcome to Cambridge IGCSE Physics Paper 6-3, October-November 2023. Question number 1. Sand is a granular material composed of very small, irregularly shaped mineral particles. A student determines the density of sand by two methods. She uses the apparatus shown in figure 1.1 and figure 1.2. So you can clearly observe figure 1.1 is an empty cylinder and its mass is given in the meter in the display. Figure 1.2 is a beaker along with sand and its mass is indicated in the display. And for your understanding, I wrote M2 and M1. Part A. The student measures the mass of a 250 centimeter cube measuring cylinder as shown in figure 1.1. She pours sand into the measuring cylinder and measures the mass of the measuring cylinder and sand as shown in figure 1.2. Use the values shown in figure 1.1 and figure 1.2 to calculate the mass m of the sand. So this is a very common type of question to find mass of the given substance when we know the mass of empty cylinder and mass of cylinder plus the content. So M2 minus M1 will give us the mass of only sand. It is 143. Already unit is given. Then the second one, the student measures the volume V1 of the sand in a measuring cylinder. It is given. Calculate a value for the density rho 1 of the sand sample. Use the values from A1 and the equation rho 1 is equal to m upon V1. Include a unit. Here directly formula is given for us and they remind us to include a unit. So it is very friendly way of asking the question. Just we need to correctly substitute the values and shouldn't forget to write the unit from the above values, that is gram per centimeter cube. Then moving to the next question, part B. The student pours 100 centimeter cube of water into the measuring cylinder containing the sample of sand. Some of the water soaks into the sand sample and she waits for the water level to become constant. Record the reading V2 of the water level in the measuring cylinder shown in figure 1.3. So just look at the figure 1.3 in your question paper or at the bottom of the page. So in between 150 and 160, we need to find out the exact water level. So we always should focus on the lower meniscus. It is 154 centimeter cube. And part 2, calculate another value for the density rho 2 of the sand sample. Use the values from A1 and B1 and the equation rho 2 is equal to m upon V2 minus k, where k is equal to 100 centimeter cube. So once again clearly density formula already given, k value also given. So just substitute the values without any errors and find out the answer. So if you notice all the answers in this question, all are three values. Whether it is a decimal or a full number, we have three significant figure. So we need to round up the obtained density rho 2 to three significant figures, that is 2.65. Once again they reminded in the above question to include the unit. So here also we need to write the unit, that is gram per centimeter cube. Moving to the next question. So here you can clearly look at the figure 1.3, how we need to find out the volume V2 from the lower meniscus. Part 3. On figure 1.4, draw an arrow showing the correct line of sight for reading the volume of water in the measuring cylinder. So our eye should always be focused on the lower meniscus of the water level. So it is clearly represented. You need not to draw the eye and struggle. Just you have to keep one arrow mark. Once again, if you draw an arrow mark, it is sufficient. Then moving on to the next question. Part C. Another student wants to determine the density of the particles in a similar sample of sand. Explain why method 1 would not be a suitable method for him to use. So clearly in method 1 there is no water used, and hence the sand level formed is not flat, and hence volume will be wrong and it will affect the density. So we can write sand particles cannot form accurate level in measuring cylinder. C2. Explain why method 2 would give a more accurate value for the density of particles in this sample of sand. So in method 2 clearly water is poured in the measuring cylinder, and hence the water level will be formed clearly, and hence we can find the volume accurately. So the density also will be accurate. Part D. Describe two possible sources of inaccuracy in the measurements taken in method 1 or method 2, even if they are carried out carefully. So, if the experiment is done carefully without any human errors, but still in method 1 we can find the sand level which is formed is not flat. So, because of that we may get some inaccuracy. And in method 1, method 2 we are using measuring cylinder, and the readings are not very close. Each line gives a 2 centimeter cube of volume. So if more readings are given on the measuring cylinder, then it would be very accurate. So we can write graduations on measuring cylinder are too large. That's all with the first question. Let's move on to the next question. Second question. A student investigates the cooling of hot water in surroundings with different temperatures. He uses the apparatus shown in figure 2.1. So just observe the apparatus clearly. There is a thermometer, and below we need to read the thermometer level. Question A. The student pours 100 centimeter cube of cold water into beaker B and places the thermometer in the water. Measure and record in the appropriate column headings of table 2.1 the temperature θ1 of the water as shown in figure 2.2. So in figure 2.2 mercury level is clearly visible, but the readings are very minute. So we need to observe carefully and take the reading and write it in the table 2.1 in the coming pages. It is for 1 mark. So clearly we can read it as 18 degrees. Part B. The student places beaker A inside beaker B as shown in figure 2.3. So observe the beakers. It is one beaker inside the other one, like a beaker is placed in water bath. So that the water in beaker B rises between the sides of two beakers. He removes the lid and pours 150 centimeter cube of hot water into beaker A. He replaces the lid and puts the thermometer into the hot water in beaker A. He records in table 2.1 the temperature theta A of water every 30 seconds. So for every 30 seconds of interval, how the hot water is cooling, we need to find. That is the experiment. Describe one precaution that can be taken to ensure that the temperature readings are as accurate as possible. So whenever thermometer is involved, we need to keep the thermometer fully immersed without touching to the bottom, without touching to the walls, and completely the bulb should be inside the hot water so that we get the accurate readings. Place the thermometer so that its bulb is completely immersed, not touching bottom or walls. Simply it is for 1 mark. Part C. The student repeats the process for water at a higher temperature theta 2 in beaker B. His readings are shown in table 2.1. So beaker A in cold water is first column, beaker A in warm water is second column, that is at higher temperature. So clearly if you observe the readings, initial temperature is 78.5 for beaker placed in cold water and its last temperature is 62. You need to find the difference and just keep it aside. Then beaker A in warm water, the starting temperature is 80 degrees and the final temperature is 70. So clearly the difference is 10 degrees. So which column has more difference in temperature? You have to observe carefully and answer the following questions. Write a conclusion stating in what way the temperature of the water surrounding in beaker A affects the rate of cooling of hot water in beaker A. So the hot water in beaker A will be fastly cooled when it is placed in cold water. It is very obvious, but we need to justify your answer by reference to values from the readings. So we need to quote the values, then we get the 2 marks. So rate of cooling is high for beaker A in cold water because temperature difference is more in cold water. That is the starting two temperature differences I have taken, starting 78.5 minus 72.5 in 30 seconds of interval, it is 6 degrees, and in the same 30 degrees 30 seconds of time interval in warm water it is only 3 degrees Celsius. So clearly rate of cooling is high in cold water. Then part D, calculate the average cooling rate R for beaker A cooling in cold water. So it is only for beaker A in cold water. We need to take the values from column 1. The formula is given. R is equal to theta A naught minus theta A 180 divided by T, and where T is 180 seconds and theta A naught and theta A 180 are the temperatures of water in beaker A at T is equal to 0 and at T is 180 seconds. Include the unit for the cooling rate. Once again, it is a friendly way of reminding us to include the unit, which is 1 mark. Substituting the values as per the given formula and including the unit will be 2 marks. So once again, if you observe the values, all the values in the table 78.5, 72.5, 80.0, 77.0, sometimes we may doubt why should I write 0 after the decimal, why should I write, because to make it 3 significant figures. So our R answer in part D also, it should be 3 significant figures, so 0.092 degrees Celsius per second. Moving to the next question, part E. Another student repeats this experiment at the same room temperature. State two other variables that she controls to in order to obtain readings as close as possible to the readings in table 2.1. So in table 2.1 already a student performed this experiment and another student is doing with the same room temperature, that is actually one control variable. So already one control variable is doing the experiment at the room temperature, and what are the other control variables means initial temperature of water must be same and volume of water that is taken in previous experiment and this experiment should be same. Then moving on to the next question. Part F. After 180 seconds, the student measures the temperature of the water surrounding beaker A in the first experiment and finds that theta 1 is equal to 49 degrees Celsius. State the reason why this can affect the results of the investigation and suggest what effect it has on the value of cooling rate R. So in the first attempt and second attempt, temperature after 180 degrees 180 seconds is not same. In the first case, it is around 62 degrees Celsius and now it is 49 degrees Celsius. So the reason is temperature is not same, so definitely it will affect on the R value. So how it will be, since the value is less, rate of cooling value when we calculate it will be a less value, so rate of cooling is decreased. Part 2, suggest one change to the experiment to reduce the effect in F1. So if we are using in both the beakers, in both the columns, if we are using the same temperature, instead of taking cold water and warm water, use same temperature water bath around beaker A, then the rate of cooling will not be affected. So with this, it is the end of second question. Thank you so much for watching my explanation, and ignore if there are any mistakes. If you feel any corrections, you can suggest in the comment box. Thank you.